Okay, so I think I'm live. So guys, just please confirm quickly whether I'm live. I mean, you guys can hear me or not. I'm audible or not. Okay. I want a quick confirmation from you guys. Well, I think I'll just check from my end. So if I find, because it's already 10, so that I'll start with it directly. By the way, I think this is not visible, right? The chat is not visible. Now the chat is also visible. Yeah, it is okay. So everyone just join quickly. Why are there so few people today? Like, not much people are over here. 3 people are watching it. So guys, just like at least be responsive. Okay, so let's start. 1, 2, 3, 4. Okay. So today we'll be discussing 4 problems. So let's start with the first one only. Okay. Chefland Library. That was the first problem, right? Yeah. Chefland Library. In a Chefland Library, there is a penalty system for late book returns with the following rules. For each book returned late, penalty points equals the number of days the book is overdue. When multiple books are returned on the same day, only the highest penalty among those books are counted. Okay, I'll just put it over here so that it's more better visible, right? LinkedIn. I'll just quickly put it on Discord so that new people may join quickly. Okay, so Chef has borrowed N books from the library for the ith book. It was returned I days late, and आज का CC uh, hard to था. But what I feel is like how come people are doing so many problems, man? Like these problems, the last two, like this is still okay, but then this problem was actually difficult, man. I don't know how people could do it. For 745 submissions on this, damn, good, good that people are doing it. So this one, right? Now what we have to do is we have to calculate the total penalty points chef must pay. Now let's understand what the problem statement tells us. Okay. So for that, we'll go to Excalibur. My rating dropped from 1450 to 1428. Even my has dropped. It dropped a huge. There was a huge drop. The drop was huge. Well, uh, only okay. You in which division, by the way? Yeah. So it is visible, right? Division 3. Okay. Now let's understand what the problem states us. Okay. So let's say if you're given an array and the array has got some few values in it. Okay. Let's say 1, 2, 1, 3, 5, 6, somewhat like this. Okay. Which means that I have returned this book. Good. Like it's 17 is still good. Like it sometimes happens. So so let's say like if I'm returning this book, it means that I was late by 1 day. I'm sorry, not one. So let's say it's like this: 1, 2, 3, 4, 5, 6. So I was late by 1 day, and I returned it on day one. Okay. Or let's say instead of taking it as day one, let's say I returned it on uh, 1st Jan. Okay. This book I returned 2 days late, and I returned it on 2nd Jan. This book I returned 3 days late, and I returned it on 1st Jan again. Now what happens is, what we have to calculate is, since we know that on a specific day, that is on 1st Jan, let's say, so what is the largest fine that I have to pay? So on 1st Jan, you can see this is 1, this is 1. So which is the largest? The largest is 3, right? So 3 is the largest fine. So on 1st Jan, okay, I think this won't be visible for you. So basically on 1st Jan, the charge is 3, right? What about 2nd? On 2nd Jan, you're returning only one book, that is 2. So charge is 2. On 3rd of Jan, it is 4. On 5th, it is 5. And on 6th, it is 6. So if you add them up, you get the answer. Okay. So let's consider one of the things that was given to us. So let's say if we consider 1121. Okay. Let's have this thing 1121. 1, sorry, 1, 1, 2, 1. Now see, 1, 2, 3, 4. Which means on 1st Jan, I'm returning this book, and this book. And what is the maximum fine that I have to pay? 1, 2, 4. So which is the maximum? 4 is it. So I have to pay 4 rupees. Okay, think it like this. And on 2nd Jan, I have to pay 3 rupees. So what is the total? 4 plus 3, 7. So is this question clear? Is this question clear with you guys? 7 people are watching this, so I guess like I can get a reply, right? At least be responsive so that I know that yeah, I can move on. Yeah. So see, how we are doing it, we are using a vector in just for the reference, the code. I'm having a, like, since I know that the range of a of I is till 10 to the 5, so I can have a 10 to the 5 comma 0, so that I can find out the maximum fine for that specific day. Okay. And after that I go for all the days and I just add the fines of them. Okay. This is as simple as that. If you want, you can take a screenshot of this, but this is it. Nothing more than that. So I'll just move on to the next problem. Okay. Sorry. In the ancient kingdom of warriors, each troop possessed unique magical powers. This is distinct power. Okay. You're given an array A of n integers, where A of I represents the power of the ith troop. All powers in A are distinct. Okay. Each troop is assigned a rank based on its power. The troop with the highest power has rank 1, and the troop with the lowest power has rank n, and the troop with the second highest power has rank 2. It is not given, but just for you to understand. Okay. So you need to remove exactly one troop from the array. When a troop is removed, the remaining troops are re-ranked from 1 to n minus 1. Obviously, because they are n minus 1 now. So it means the ranking will be from 1 to n minus 1 only. So in simple terms, what we have to do is find the count of the distinct rank arrays. Okay, that is how many different arrays of B size of n minus 1 you can get after removing one troop. Let's understand what it is, and let's understand this with an example directly. Okay. Um, let's take this example because I think I have taken this example already. in the videos that I published. Okay, so we are going to have 914 this thing. Brother, I'll just do one thing. I'll just make it a little bit bigger for you to understand. Okay, so now we have got the array. Okay, how many you did? Uh, 1, 2, 3, 4, 4, just 4. Okay, so we got the array. Okay, 9, 1, 4, 12, 12, 7. Now let's have the corresponding ranking array for it. Okay, now we know that if we rank it, so 12 is the largest, then 9, then 7, then 4, then 1. So 9 is in, so this is the first, second, third, fourth, fifth. So 9 is in second position, 1 is in fifth position, 4 is in fourth position, 12 is in first position, and 7 is in, hmm, and 7 is in third position. Okay. Now since you know that, since you have got the whole matrix thing, okay, just a minute, I just need to follow my other devices footsteps. So now since you have got this, okay, let me just make it a little zoom out. So what you have to do is, so let's say if I'm removing this 2, okay, so what does it become? Anything that is after 2 gets reduced by 1. That is, this becomes 4, 3, 1, 2. Okay, that's it. Anything after 2 becomes reduced by 1. So first of all, I get 4, 3, 1, 2. Let's do one thing. For our understanding, this 4, 3, this thing, sorry, I have to delete this also. So for our understanding, let me write it in a different color, 4, 3, 1, 2. Now, if I'm going to delete this 5, it means anything after 5 is going to be minus 1. But it is 2, 4, 1, 3. Anything, nothing is after 5. So another is 2, 4, 1, 3. Right? Now, similarly, if I go on to delete this 4, which means that it is going to be 2, 4, 1, 3. That is 2, 4, 1, 3 again. Okay? Is it visible now? Okay? 2, 4, 1, 3. Now let's say if I'm going to remove this also, remove the 1 over here. So which means everything gets reduced by 1. That is 1, 4, 3, 2. That is 1, 4, 3, 2. Okay? And if I'm going to remove the 3, it becomes 2, 4, 3, 1. So 2, 4, 3, 1. So how many total are there? 4, 3, 1, 2, 2, 4, 1, 3. But you can see that 2, 4, 1, 3 was repeated. So 1, 4, 3, 2, 2, 4, 3, 1. So there were total 4 different uniques. Okay. There were total 4 different uniques. So what was the answer for this? It was 4. Okay. But how can we do it? So for this, you have to notice a pattern in it. Okay. What is the pattern? The pattern is that, just a minute. Well, the pattern is that when did we get the same thing? Okay, you have to find out when did we get the same thing. The same thing we got only when we transition from 5 to 4, right? And why did we transition from 5 to 4? Like, why did we get the same thing? Because it is having a difference of 1, which means that if it is having a difference of 1, okay, so what 5 does? It reduces everything after it by 1. And what 4 will do is, it will also reduce everything after it by 1, right? Now let's say anything after 5 is going to be same as anything after 4 except 5, right? Anything after 5 is same thing that is after 4 but except 5. But since anything after 4 is sorry, let me just, I think this thing I have to like explain you why does this happen. Okay, so let's say if you have a number x and a x plus 1, if they are consecutive, and if you remove this, the specific permutation that you get is same as if you remove this, the permutation you're going to get. I mean, by permutation I mean the ranking matrix, ranking array. Okay, why is it so? Now I'm going to explain it. Okay, so anything after x plus 1 is same as anything after x plus x plus 1, right? Is this clear? Quickly tell me, is this clear or not? Perfectly audible, right? So I just think that I'll just I'm just considering that it's clear. Okay, so basically anything after x plus 1 is same as anything after x apart from x plus 1. What do I mean by that? Let's say if x plus 1 is 3 and x is 2, so what is after 3? It is 4, 5, 6 dot dot dot, right? Or rather, I think it's not visible for you. So what is anything after 3? It is 4, 5, 6 dot dot dot, right? And what is after 2? It is 3, 4 dot dot dot. That is, apart from 3, everything is this. Now what do we have, like what do we see in it? What was the pattern? That anything after that gets minus 1, right? So if everything after that gets minus 1, which by default means that this 3, if it is there, so what does this become? This becomes 3, 4, 5 dot dot dot, right? Everything after that. And over here also the same thing happens. After that everything becomes 2, 3, 4 dot dot dot, right? Now since this 2, it won't change, so in this case also the 2 won't change. Clear? Not clear? I get it. I'll explain it again because I get it, like it's not that clear. Well, let's say if I'm having 2, 3, 4, 5, okay, and now I have a 3 and a 4. So if I remove 4, so anything after that becomes minus 1. That means 2 and 3 remains the same and 5 becomes 4. But if I remove 3, what happens? Everything after that becomes minus 1, which also means that 5 becomes 4, but 4 also now becomes 3. But since I am removing 3, okay, since 3 is removed, so it's basically like removing this 3 and writing it over here. So it's basically the same as removing 4, right? So that's the reason, that's the thing, that's the trick of the whole problem. That is, there will be total uh, n possible answers. Okay, what are the n possible answers? Like removing any one of the n elements. That is the all n possible answers, except for the fact if the previous element is plus minus 1 of x, then we don't consider that because it is going to result the same thing. Okay, so let's have a look at the code. Br of I, so this is something that I do for making the ranking matrix. So I just copy the values of ARR into BRR and then I sort it out and I put an ordered map for rank so that I can get the rank matrix. Okay, I get the rank matrix and I make ARR of I make the ARR matrix as a rank matrix. Okay, and after that what I do is in the rank matrix I do the same operation, that is if the previous element and the current element is having a difference of 1. So sorry, so let me just introduce this also. So initially answer is equal to n, that is by removing every element I get a unique permutation or unique rank unique rank array. Okay, but what if there are more than one similarities? The similarity will happen only if AR of I minus AR of I minus 1 is having an absolute value of 1. So is it clear why it is happening so and how the code works? Because if it is clear, then I'll move on to the next problem. Okay. Anyways, people new to this channel, I'll just request you to subscribe my channel and like this video. So is it clear? Like, otherwise I can't move on to the next problem. Okay. So should I move on to C? Or let's say, is B clear? Why can't I start a poll? Yeah. Oh, okay. It was because like there were two pinned things. Okay, so B is clear, right? One vote, clear. Since there is no other response from anyone else, I'll just assume that it is clear. So let's move on to the next problem. C. Costly permutation. Every Christmas, chef has a peculiar tradition of gifting a permutation P of length n. For each index I in the permutation, there is an associated value V of I. The value V of I is the number of steps needed to return to the index I when following this path. Okay. What is V of I? We don't know. We are going to get it. Okay. We are going to know it real soon. So start at index I. So here he tells us how we are calculating the V of I. Start at index I, let the current index be k, then move on to the index P of k, continue until you return to index I. Okay, so it is basically a cycle. It is kind of a cycle. So let's say for this 3 2 5 4 1, if we are at index 3, that is over here 5. So from this 5 we go to the fifth position, that is 1. So which tells us to go to the first position, that is 3. Then again to the third position, that is 5. So we kind of return back to the position that we started from. So it was 3 5 1 3. Okay. So what was the length of the cycle for this? It was 3, right? Because there were 3 elements, 3, 5 and 1 in it, right? Clear? Very easy. Chef can perform operations to modify the permutation. In one operation, he can swap elements at position I and j. Cost of the swap is V of I plus V of j. Okay? We know what is V of I and what is V of anything, V of I. After the swap, values V of I and V of j and possibly others will change. Obviously, it will change. Okay? Clear? Chef goal is to transform the permutation to achieve the maximum okay. Chef's goal is to transform the permutation to achieve a maximum possible sum of all values. Okay. Return the minimum total cost to achieve the maximum possible sum of values. Too complex? Not at all complex. Okay. So let's say in an array there is a cycle. Cycle is from here to here, from here to here, back over here, then over here, then over here. Okay, this is a cycle, this is a possible cycle. There is another cycle which is from here to here. Okay, so how many cycles are there? There are two cycles, right? So we have to maximize for every specific position. We have to maximize the length of cycle. So we know that the length of cycle for these positions, for the red positions, go to the same because they are connected together. Okay, since these positions are connected together, so these positions are going to have the same cycle length, that is 1 2 3 4 5. Okay, so red is 5, and for the blue it is going to be, there are two elements, so for blue it is 2, right? Why is 2 not visible? I think there is some issue with reloading it. Yeah, now it is visible. Well, so it will be 2, right? So 2 and 5. Now we have to make it as much as possible. So what is the total of it? Like it's going to seem like this, right? 5 2 5 5 5 5 2. What do I mean? It is going to be like this: 5 2 5 5 5 5 2, right? But we have to make the whole sum of it as maximum as possible. And what is the maximum for one specific position that I can make it? It is the value of the whole, the length of the whole array. That is 7. Okay. So can I make this 5 as 7? See, if I make this 5 as 7, it means all of the elements are connected in the same cycle, which makes all the elements 7. Okay. So if it is possible, then this is the best approach. So first of all, let us prove that it is always possible to make every specific element. It is always possible to make every specific element uh, having the value of n. Okay. How can we do it? Now visualize this as cycles in a graph. Okay. Or like trees, more like trees. Consider them. So let's say there is a cycle. This is a cycle, right? These are the elements of the array. Like you just have to visualize it in a different manner. So that is, there was five, five blue points, right? So these are connected, and there are two red points, and overall this is the whole array. Now how can we make the cycle merged? So we have to make the cycle merged. So what can we do is we can remove this and this. Okay, and after that, in spite of this, I can have a blue like this, and in spite of this, sorry, red was already there, so I can have a blue like this and then a red like this, right? It is a possible thing. How to do it? That is the most important thing. So let's say if we swap them out, okay, this blue becomes this, and this red becomes this, which means that this red is connected to this, right? This red is connected to this. Let me just erase this lines. So this red is connected to this, and this blue is connected to this. Sorry, this blue is connected to this. Clear? Now since it is a permutation, so this is also connected to this. So is it clear like how we are making this? Is it clear how we are making this cycle? by just exchanging one from red to one from blue. That's it. Is this part clear with you guys? Anyways, since the watching was good a few minutes ago, so anyways, people who are watching this, please do subscribe my channel and like this video. That's it, nothing else. Okay. So is this clear? Like this cycle thing, like how we are making the whole thing as a cycle, and it is always possible to do it. So let's say if there was a green also of size 3, okay, the same thing we could have done it. We could have replaced this green with blue, and we can do it in like in a chain method also. So let's say if we are having various cycles, okay, we are having one cycle like this, another cycle like this, okay, another cycle like this. We can connect all of them. How can we do it? We can replace this and this, then we can replace this and this, let's say, okay, and thus there is a cycle in it. Thus we get a cycle in it, nothing else. Is it clear? Guys, just be a little bit responsive so that I can like move on real fast. Because I'm just assuming that it is clear, okay. I don't know why there's so less views today, but it's okay. Okay, so now we have to minimize it. We have to minimize the cost of it. How can we do it? We can find the minimum of all these phone nodes. Let me like use a different color for it. So we have to find the minimum of all these 4 nodes, then find the minimum of all these 3 nodes, then find the minimum of all these nodes, okay. So first of all, you may ask that which is the best possible way to connect it, okay. Now since we know that the formula for every costing is going to be v1 plus v2, okay, more like vi plus vj, so v1 plus v2. So let's say if I'm having 4 nodes, okay, 1, 2, 3 and 4. So first of all, let's say if I'm connecting this 1 and 2, it becomes 3. And if I'm connecting this 3 and 3, it becomes 6. Okay. And then if I connect this 6 and 4, it becomes 10. So total, what was the total cost of it? It was 10, right? But what if I tried something different? So let's say if I've connected like 3 and this 3, and then 4 and 3, that is 4, 5, 7, and this 3 and 7, 10. Same thing, right? You may come up with that. That is the same thing only. But what if I did this, the alternative thing? Okay. That is 4 plus 3, 7, and 7 plus 2, 9, then 9 plus 1, 10. So basically, like you may come up with the fact that no matter whatever it is going to be the same. But that is the wrong concept, because we were using 1, 2, 3, 4. If we use 1, 3, 5, 7, 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, right? Do the opposite thing. 5 plus 7, 7, 8, 9, 10, 11, 12, 12. 12 plus 3, 15. Just a minute. After finding number of cycles, how we are sure that after swapping one node from 2 cycles, both become one? Okay, you're not you. Okay, just let me tell you. how you have to be sure. Okay, so let's say if I'm having a cycle like this, okay, and if I'm having a cycle like this, clear? So if I'm swapping this and this, okay, now we know one thing. Now the connections will be different, right? Which means that let if I erase this and this, now the new red node is over here and the old blue node is over here, right? Clear? Which makes a fact that, so let me erase this too, okay? Because this was erased. Let's say this was erased. Now which means that this will be this will be connected to this, right? And this will be connected to this, right? We know that. But since we are in a cyclic graph, okay, and in a cyclic graph, what happens is like we are in a permutation, right? We are in a permutation, which means that one specific element is going to be originated from one point and it's going to be ended at one point, right? Because we know that since there is a cycle, since every element is in a cycle, it means that it comes from one point and it goes to another point. So it is connected to 2 points every time, no matter whatever it is. Okay. So how can we find out that what this point will be connected to? Now, since I replaced this with the previous one, so it is connected to this. Clear? Works. If you want an example, we can show it also like that. I can show it also like that. So let's say one, mm, got it? Okay. Now about the concept that we have to do is, I don't know how many of you have heard of this thing where like, I think you guys have, like people who have studied memory storage. Okay, memory storage. Wait, why? Why? Any doubt? Continue. Okay, wait, continue. Okay, I thought you got any doubt. Okay. So now let's say if you know the like structure for this like device storage, okay, so there is an algorithm where there's a tree algorithm basically. Okay, something like that. Where if you're having specific hard drives and if you're just merging them, concatenating them together, so it is like always a better approach to do it in a very what to say? Just a minute, because I can't recollect the algorithm. Hard drive storage algorithm concatenation, whatever is coming to my mind. But anyways, I can't recall what the algorithm was basically, but I can explain you what the algorithm is basically. Okay, so let's say if you're having a few elements, so 1 comma 1 comma 3 comma 5 comma sorry 3 comma 4 comma 6. Okay, so let me show you a approach that you shouldn't follow to do this merging. So basically 4 plus 6 is 10, 10 plus 3 is 13, 13 plus 1 is 14, 14 plus 1 is 15, right? Now if you add them all together, okay, it's going to be a very bad approach to you. Okay, actually I think I'm not being able to make you understand like the actual algorithm that works behind this. Can't think of a different example actually, like where the tree is broken. Actually the algorithm is like if you're having this, so first of all you have to start with the lowest numbers, that is 1 and 1, you get 2. Okay, and then you have to like replace this 1 and 1 with 2, and then again go for the lowest two numbers, that is 5, and then replace with 4 5 6, this whole thing, and now again the lowest two numbers, that is 9, and then 6, and then add it up. Okay, but what if there is something like which is not going to work that way? 1 1 1 2. Okay, I think I got a yeah, use priority queue exactly like this one. I have used that only. Priority queue, but like just to understand, just to make you understand like how the thing works is very essential. Just using something in spite of knowing like why do we use that, it's a very illogical logic. Okay, so let's say if we are having 2233. Okay, I think this should work. This is the costly permutation problem, the third one. So 2233. Now if you like do this, 2 plus 3 5, then 5, then 10, 4 5 7 8 and 10. Anyways, like the costing is very like that. Okay, so what you have to do is basically like let's say if you're having 2 2 3 3, I can't recollect a good test case. Okay, can't think of a good test case. So if you're having like this, so what you have to do is you have to just take out the minimum two elements from here, and you get 4, and then add it over here. Okay, so it becomes 3 3 4 4 5, or rather replace that elements with that. Okay, replace these two elements with 4. So now you take out the next two minimum elements, that is 3 and 3. Could you explain costly permutation? I'm explaining costly permutation only. Okay, so you can remove this 3 and 3, and now it becomes 6. Now what is the two minimum elements over here? It is 4 and 4, right? So this 4 and 4 gets replaced with 8. Now the minimum elements are 4 and 5, right? So we remove 4 and 5, and it becomes 9. The two minimum elements are 6 and 8. So we remove it, it becomes 14 and 9. And 14 and 9, if we remove it, it becomes 25. Clear? So that's how we are going to do it. Okay, so basically let me just take it over here, and I'll just explain you what we are doing it. Okay, see, first of all, I'm having AR of I. Okay, I'm just taking the inputs, but I am also making AR of I minus minus because I have to adjust the zero based indexing. Okay, since over here we know that it is one based indexing, 1 to n, we have to make it zero based. Okay, so that's the reason we are making it. Then I'm having a visited and a cycle length, so that by that I can find out all the cycles that are there in the whole array. Okay, so I'm detecting the cycles. For every cycle I'm going to check if we have already visited that element or not. So if we have not visited that element, that means it is there in a different cycle. Okay, so then we find the cycle length, that is while the current element is not visited, you just go on repeating the cycle. Okay, until unless you reach the specific element, and the cycle length gets on increasing. Okay, so you get the cycle length. After that, you use a priority queue to minimize the merge cost, because you have to merge all of the cycles, right? So that it now becomes one whole cycle. So use a greater thing so that you get the greater elements. And after that, what you can do is you just put the length out one by one, just pop the lengths one by one, and then add it to the total cost, that is the result for you, and then again push back the length 1 plus length 2 to your main to your priority queue that I was doing over here. Okay, but I can't recollect what this algorithm is called, but it is something related to like memory storage and something like that. I don't remember. This algorithm is used to like I mean concatenate memories in hard drives, so that you have to like have it at a very less cost. This is something related to operating system, or um, I don't remember actually. Something related to operating system, I guess. So is the problem clear for you guys? Like, is it clear or is it not clear? So that I'll explain you again and tell me which part is not clear. Okay. Clear. Okay, that's good. Like merging patterns. Okay, you didn't get the merging patterns. At least write no over here because there are three words for yes. Like if you're not getting, okay, okay, okay. So got it. Can you explain divisor array? Divisor arrays? Yeah, I'll explain the easy version. I haven't done the hard version. Okay. Okay, so let me explain the merging pattern. Okay. The merging pattern is like, so let's say if you're having two cycles, then it is very simple. If you're merging it, it means that this cycle was value, this cycle, the V of everything was 4, and over here it was 2. Okay. And if you're merging, then it becomes 4 plus 2. That is 6. It is very clear. But what if you're having more than this? Okay. There is also another cycle of size 3. So you have to understand which you have to merge first. Because if you're merging this and this, so this becomes 5. Now there is a new cycle which is 5. Then you merge 5 and 4, right? Otherwise, what you can do is you can merge this with this and then the whole thing, or you can merge this with this and then the whole thing. Okay, which makes it that either you add this, it becomes 6. Okay, so you get the 6 and then you add 6 plus 9. That is total cost is 9 plus 6. Okay, okay, now I got it. Now I got it. I can explain you. Okay, I can explain you. So basically 9 plus 6, that is 15, right? So this is one approach. Now see, if you're having 3, 5, so what was it? I forgot. It was 4, 2, 3, right? So let's say if you're having 4, 2, 3, that means 2, 3, 4, okay? 2, 3, 4. So what you can do is you can add this up. So it becomes 7. So you get a cost of 7. I'm lagging a lot. I think my Excalibur is lagging a lot. Well, okay. Am I lagging a lot from my video and audio also? No, no, no. I think that's perfect. That's perfectly clear. Anyways, people new to this channel, just to subscribe my channel and like this video, okay? Because that motivates me to make more videos. So, anyways, so this is going to, if you're merging 4 and 3, it's going to take you a 7, like cost of 7. Then the 7 that you're getting, you have to add it to over here. 7 plus 2, 9. Okay, so 9 plus 7, which makes it 16. So one of the approach gave us the result of 16. Okay, but if we do it the opposite way, only notepad. Okay, only notepad, yeah. So if you do it the opposite way, that is, if you're having 2 and 3 and merging them, which makes it 5. Okay, so I'm having a value of 5, and then 5 and 4, that is 9. So 9 plus 5 is 14, which is better than 16, right? So what is the approach of doing this, of the merge? Sorry, the merge approach is using one algorithm that is already there. So whatever values are there, you have to just put it in a priority queue. Okay, whatever values are there. So let's say A, B, C, D, E, F, dot, dot, dot. Whatever values are there, put it in a priority queue. Take two minimum elements, the two minimum elements from here, add it up, add that to, bro, if you don't mind, I couldn't understand test cases of Chefland Library. Chance, can you explain again? Chefland Library. Mm, okay, I'll just go through it after I explain this, okay? Now see, you have to add it up, add it to the answer, and then whatever the result you got, you have to push back to the priority queue and remove these two values. Again, take out two minimum elements. I'm not a pro, man. Take out two minimum elements, add it out, add it to the answer. Whatever the add you got, put it back and remove two elements that you got. Okay, so that's it. Like, you have to do it. So I think now if I go through the walk you through the code, you'll understand it. Okay. So for first of all, we are going to detect the cycles. This is a very easy code. You can get it anywhere. I think there are a lot of resources to get this. The priority queue, super chats, huh? I was actually experimenting with the super chats, but it's okay. Like, you don't have to pay. Okay. So basically, you're having a priority queue. Okay, PQ, cycle lengths begin. So I'm just sorting the whole thing on the basis of greater. Okay, and after that, I put out a length. Okay, which is minimum over here. I put out the two minimum lengths from the priority queue, add them up and add it to the total cost, and then I push back the addition of the lengths, and finally I get the answer as total cost. So I do this until and unless I feel that I am, like, the last one element is left. Okay, till that I go on doing it. That is I was explaining. So now is it clear? It's 100% yes. Yeah, good. Four votes and it's a yes. So we can move on to the next problem, right? Well, division array is easy version. Okay. Chef has received a mathematics assignment that requires array transformations. Given an array A of size n and a positive integer m, perform these steps. First, create array B such that B of I is equal to A of I into m factorial. Then for each element in array B, calculate f of B of I, where f of x represents the number of divisor of x. Okay. Since these values can be large, output each f of B of I modulo 10 to the power 9 plus 7. The whole problem, you skipped my question. Anyways, I think I just promised someone that I will be explaining a test case for Chefland. Okay, I'm just also running out of charge. Just a minute. Okay, so I was supposed to explain you the first question. No? A test case of the first question. Let me explain it quickly. Chefland Library, that is no voice. You still can't hear me. You still can't hear me or not? Like, because from my end it's showing that there is voice. You still can't hear me or not? Like, because from yeah, working. Yeah, I think it's working. Yeah. So, anyways, like what it basically meant is that just think it like this: that on the first day of the month, so what you can do is, yeah, I get it, I get it. No audible, yeah, I get it. So on the first day of the month, let's say you're having two books to return. Okay, so you have to consider the book that is going to give you the more fine. That is the second one. And on the second day of the month, you're going to return the book that is going to give you the most fine. That is the fourth one. So 4 plus 2, that is 6. Okay. So for every specific unique element, you have to find out the maximum position that it occurs in. Okay. So you can have an unordered array. I mean, you can just rewind back and get it. Okay. Just because you just couldn't understand the test case I just mentioned you, that is, this is at the second position, and the maximum 2 is occurring in the fourth position. So 4 plus 2, 6. For this 1, 2, 3, 1 is occurring at the first, then 2 is occurring in the second, and 3 at the third. So 3 plus 2 plus 1, that is 6. And over here, 1 and 2, 2 is occurring at the third position, and 1 is occurring at the fourth position, the last one. So that is 4 plus 3, that is 7. Okay, so that's it. Anyways, let's move on to the problem that I was discussing. This is the V1, right? Okay. Now let's understand. For this, I'll just go through the code first, okay, and then I'll explain you, because there is no much of explanation for this problem. If you allow, can I share the easier version of it? Yeah, the easier version is this one that M4 mentioned, that use a map and maximum of MP I, I plus 1. But since like like in the beginning portion, so whatever code you do it, you just don't think of optimizing it more. So it just came to my mind. I just coded it quickly and then submitted, and it worked. So I just didn't work on it. Yeah, but this is a better version, I guess. But anyways, you can always do it. Okay, you can share. It's okay. So let's understand. Okay, so I'm using sieve of Eratosthenes to find all the primes up to a maximum limit. Why maximum limit? Because it was given that the values of n doesn't exceed 10 to the power 5. Okay. After that, so this is a very simple sieve of Eratosthenes. Again, this thing you can find it on any AI tool can solve it for you. You can find it on GFGI also, I guess. I'm not sure, but yeah, any AI tool can solve it for you. Okay, because this is sieve of Eratosthenes. Because if you don't know this, I'll just go through it. I'll just quickly what sieve of Eratosthenes is, just for people who are new. Sieve of Eratosthenes works like this, like it. So I'll just explain a very easy problem of sieve of Eratosthenes, where if you're having specific numbers, okay, and you have to find out all the prime numbers in it. So let's say if I'm having 1, 2, 3, sorry, 1, 2, 3, 4, dot dot dot, 11, 12, dot dot dot. Okay, somewhat like this. So what I can do is, it was on campus for me, but it hires most of off campus. Okay. So basically for this, what we can do is, so for like we know that one is a like one we don't consider it, but for two is a prime number, but all its factors are not prime numbers, right? So we can remove all its factors, all the factors of 2, that is 4, 6, 8, 10, 12, 14, 16. So we can go on cancelling them. Then we find 3 and then cancel all the factors of it. Not the factors, sorry, all the multiples of it. Okay. So basically, that is how what we can, yeah, exactly, all the multiples of it. So that's how you can find out all the prime numbers by using sieve of Eratosthenes. Okay. So that's it only. That's what I have done over here. Then I have a function to calculate the prime factorization of a number. Okay. So I'm also finding the prime factorization of a number. It's very simple. It's like all the primes that are there in the range. I can put them, and if I find that it is going to be divided by that, then I just add it, then otherwise I don't add it. So basically what I'm doing is this CO of Eratosthenes does what? Since we know that it is not going to exceed 10 to the power 5, so we can have a specific limit for it. Okay, you can see that when I call the sieve, I call it with maximum of A, that is 10 to the power 5. Okay, this is 10 to the power 5 because I don't need anything after 10 to the power 5. So that is the reason, like it is going to minimize our workflow. Okay, so after that I have a function to calculate the prime factorization of a number. Then I have a function to merge two prime factorizations. Okay, so whatever I get from two prime factorization, I can merge them up because it was given that create B such that B of I is equal to A of I into M factorial, right? So we have to merge the factorizations also. Calculate the number of divisor modulo mod. This is because we know that since the value can be very high, so we have to like give it at a modulo 10 to the 9 plus 7. Okay, so for each element in array B, we have to calculate f of B, which represents the number of divisor of X modulo mod. Okay, so whatever the number of divisors are, you can mod it with mod. Okay, this is also a very simple formula. I don't know how many of you have come across this. Why did my Excalibur become black? This is also a very simple formula. Basically, like if you guys have come across this, it is like if there is various prime factors. So let's say p to the power x, p1 to the power x, and p2 to the power y. So this is how a number can be represented as. So number of devices is going to be 1 plus x into 1 plus y. Oops. 1 plus x into 1 plus y. Okay, so this is somewhat like that, and it can happen like there can be more than this 1 plus z or more than that. Okay, so that's a formula. So that's a formula that I've used for this. Okay, divisor into power plus 1 mod. After that, what I do is I take the input, and now the main thing comes. I pre-compute all the primes using sieve of Eratosthenes. I compute m factorial and its prime factorization. Okay, I can do it. And then what I do is I have to merge the factors of the factors and m factorization. So the factorial is basically like I can multiply all the numbers like this. But since it is going to be like, let's say, how can I find the factors in a specific number? By having its prime factorization. Okay, now since I already have a prime factorization function ahead, so using that I can compute them. Okay, and step 3 is process each a of I. That is, each a of I I'm going to multiply with m factorial and then merge the factors. Okay, so this is like merging it again. Vector long answer. So b factorization. So I have to now factorize the b. So obviously b factorization equal to m factorization, because whatever the factors of b are and whatever the factors of m are, so the factors of m are already in b, right? Because b is a multiple of m. B is a multiple of m. So factorization of factorization of m are already in b. Apart from that, we have to merge whatever there is in a. Okay. So what we do is we are going to merge factors of b and a. Okay. And after that, we can push that to calculate divisors and calculate divisors. So basically, more than this part, like this is a very sequential thing that was given to us and we did it. More than this part, what was more necessary was the function that I told you. This first thing, the sieve of Eratosthenes. Second thing, the function to calculate the prime factorization. So this is also simple. This also you can find it on any AI tool or GFG also. So I didn't explain it. And there is a merge two prime factorizations. Okay, This is also simple, like it's basically like base of prime plus equal to power. It's like uh, if you are going to merge two prime factorization, so let's say for this p1 x and for some other thing I got p1 of mm, a. So basically on merging them it becomes p of 1, sorry, p of 1 a plus x, right? So that's it, very simple. Yeah, it is lagging, I get it. So is it clear? Is it clear for you? What you can do is you can have a screenshot of it. Let me do one thing. So if you're coding it, like if you're like practicing it after contest, post contest, like if you're just looking at the if you're not looking at the live video, instead of you're looking at the pre-recorded video, so you can pause it and code the functions one by one. So you can have the sieve function, then you can have the factors function. Okay, I'm just pausing so that you guys can have a look at it. Then you can have the function to merge. Okay, then you can have the calculate number of devices modulo mod. Okay, then you can have the, this is not needed, okay, this is not needed. Then you can have the main function. This is a step 1, step 2, step 3, and then the result. Okay, so that's it from my side. Any doubts? Other problems I haven't done. Okay, other ones I haven't done. This is the harder version, I guess. Yeah. Distinct problem. Distinct problem. Okay, distinct power. Distinct power, I think I have explained already. Just a minute, I'll just check it. Right? What is distinct power, by the way? Nothing more than that. So I'll just move on to the next problem. Yeah, distinct power I've already explained. So if you're having any problem to understand it, like if you haven't gone through it, then you can just after I end the stream, you can just go back to the pre-recorded. In the pre-recorded version, you can go back. So if you're having any doubt, you can just tell me on which part did you have the doubt. Okay, so that I'll just explain that part only. Like I'm waiting for you. Okay, you'll go to the recorded video. Good. You solved it. You solved which one? This one, hard version. Okay. Anyways, like let me read the problems. Chefland Library, distinct power, possible permutation division. So if I read them one by one, easy. This is hard. This is medium. Easy. Impossible. I'm lagging a lot. Distinct, oh, distinct power. Yeah, good. Okay, so these things. So the first problem, Chefland was easy. Okay, Chefland was easy. Uh, B was distinct power. Distinct power was which problem? It was medium. The third problem was costly permutation. Costly permutation, since it needed a lot of predefined knowledge. So yeah, it was sorry, was somewhat around hard and medium. D was also somewhat around hard and medium. E was hard, and F and G, right? A B C D E F. So E and F. So yeah, that's it. That's how I read it out. E was hard and F was harder. So anyways, that's it from my side. I'll just stop the stream. Okay. Okay. So that's it from my side. Thank you.